Hello everyone, welcome to my channel. Yes, I can crack the interviews using Java. Today we are going to solve a problem of binary tree root to leaf traversal. Whenever there is a term called binary tree in any of the interview, you make sure that you know how to convert that binary tree into the Java data structure. And how do you do that? You just define a tree node, which is a separate class and has a left and right child and has a value of each child. Once you define the node right here, let's say in my binary tree I have a root as 1. I said tree node root, you can name it whatever you want. uh, Tree node is 1. Now left to 1 is 2, root dot left is 2, and root dot right is 3. You can say root dot right is 3. Order doesn't matter. The matter most is that you have clearly defined the path. So once you define the tree node according to the binary tree whatsoever be the part of the problem, you can call your function and you pass your root node into it. When you are passing a root node, just make sure in your mind that this is no more the value of 1, which is what we have defined. This is the whole set of hierarchy of your binary tree. It means that you can traverse within the binary tree using this node. And when we call it as a node, it may contain left and right value at any point of time until unless it's not a leaf. So I am calling my function binary tree with the root. Now, since I have a root, meaning that I have hold this data structure in place, now what I have to check whether my root node is null or not, which is a condition. Before than that, I have just initialized a linked list as a path, which will be containing the output of this program, and we will see over the period of time that how it is getting filled. Now I have defined another data structure called linked list for as a node stack. And what does it contain? It contains whole node, actually not just the value. It just contains the whole node into it. So we will see later on. And then I have defined the path, which is nothing but 1 to 2, 2 to 6, 6 to 8, which is a string value. So now since I have defined the node stack and the path, I have to initialize both the data structures. So I have just added my root to the node stack, and I have added the initial value, which is 1, in the path, which is my starting point, and you can see right here. Okay, so now my root is added, my path is added. What next? Next is that how we can traverse against this root to all the nodes within a given binary tree. So let's call it two local variables. Tree node is a node and string path is a path, and we'll see how it is going to be used. This is the thumb rule that whenever you are having anything like a queue or a stack sort of thing, or a linked list, make sure that you have a while loop with not empty condition, because this is the whole crux of most of the binary tree problems, which is where you go inside the loop, you deliberately initialize this to the root so that it can come inside the while loop. Once it is there, you can traverse over and you can do whatever business logic you want to perform. So I'm in the root. I said root stack.pool last. You can do a pool based on the problem to problem. I have set path equal to path.stack pool last as well. So my node will be, in this particular case, is the first node, which is a root node. Path will be, the value of path will be 1. If both the nodes are null, if both the left and right of this is null, like in this case, in this case, in this case, it means it is a leaf. You cannot traverse anymore. This, you have completed the whole path. You just add the value of the path what you have right here. Second thing is that, let's say if it is not a loop, it's not a leaf, then you have to go to the left child of the node and see if it is not null. Then what you have to do, you have to add that node again to the stack. And once you have added this node to the stack, you can go and to the path and add the value from the root to that particular node into the another variable, which is my path stack. And likewise you will be checking in that particular node that if it has a left or right, and in this case it has right, just add the value of right to the node stack and put the path from left to right and keep going. So you can see that you are keep filling your linked list right here, and here you are making sure that it is getting popped up, or it is getting the value retrieved back for your business logic. So at some point of time, what will happen in this whole logic, that this will be the condition for each node, and once this you reach to this point, it will not be anymore in your this stack. No node will exist and it will become empty and you are outside of that, and by the time your path is filled with the value of whole traversal tree. And now we wanted to print this path as a outcome of it. Let's run it out and see what is the path we are going to see. So I'm just running it as a Java program right now. What do you expect? Someone can tell me. I can hide it if you want. It's I don't want to show. If anyone want to guess it for a second, you can guess it. I can see some of the paths like 1 2 6 8. So let's take a look where it is that path 1 2 6 8. Yes, I can see the path 1 2 6 7. Yes, I can see the path 1 2 6 7. I can see the path in my binary tree 1 2 5 1 2 5. Yes, this is the another path. I saw the path 1 3. Yes, 1 3, and that's pretty much all the edges we have covered as part of this particular program. And that's what was the question in the interview, that how can you traverse from the root to the leaf for each possible combination, and which is what is the outcome of this program. For your convenience, I put some sort of system out so that you can understand what it does internally. First step, it is going to 1, then it is going to 2, then it is going to 3, then it is going to 6, and then it is going to 5, 8, 7, and that's how it is getting created all this path. Now quickly take a look about time complexity of this program. Whenever the binary tree node comes, you might aware of that you have to traverse all the nodes most likely, until unless it is a range or some kind of problem which we can discuss in following videos. But in this case, n, it's an order of n, which is n is nothing but a number of nodes, and your space, like to store all the n nodes, so your space complexity is order of n as well. Just feel free to look into this PPT as well as this code and let me know your inputs. I have put some tips and tricks. Don't worry about the optimal solution when you are in the interview. You try to implement it as you want and make it optimized later on, which is much easier than try to figure it out the optimized solution at the start. And hopefully this video will help you to understand the binary tree traverser. See you in the next video, which is going to be average of each node in a binary tree. See you there. Thank you.